Good morning, class 9. Already we have discussed few things regarding that thermal capacity, specific heat and thermal equilibrium, these kind of things. Now we are the middle of the chapter. So right now we will discuss that is called water equivalent. Now water and equivalent with heat, it is very confusing matter, but I will make it clear, just like a story. So suppose you are having a glass of water. This is your glass of water. Clear? No need to think too much. Just listen me carefully. Suppose you are having a glass of water. Now at the same times you are having 100 degree Celsius a object which contain 100 degree Celsius temperature. Clear? So if suppose you want to increase the temperature from 100 degree to 101 degree Celsius, so you need some heat. Clear? So suppose to increase from 100 to 100, suppose 150 degree, that will be easy to remember. Now suppose to increase the temperature of the object from 100 to 150 degree, you need suppose 5 joule of energy, remember. So that 5 joule of energy or heat energy if I give to this water. Clear? So this 5 joule of energy if I give to this water, so obviously the temperature of the water will be increased somehow, means it not might be for 50 degree just like that iron ball what I have taken earlier, but it might be something, it might be increase of temperature, suppose 10 degree, 5 degree or something. So right now what we will do, we will get an equivalence in between water and heat. What is that? So actually water equivalent of the body is the mass of water. So suppose this is the amount of water or mass of water whose temperature rises by unity. So here how much temperature rises? 50 degrees Celsius. So suppose here 1 degree Celsius increase by the heat which can be raised the temperature of the body by unity. So what I am telling, so if here temperature increases suppose 50 degree Celsius, so that for 50 degree increase of temperature I need 5 joule of energy. So if I give that 5 joule of energy, then the whole water is not, but among this whole water some part of the water, or if this water is 10 kg of water is here, so in between 10 kg it might be possible among 10 kg 2 kg water temperature rises 1 degree Celsius, might be possible. So that much of amount means that 2 kg is equivalent to this heat energy. In other words, we can say that water equivalent of a substance is equal to the amount of water needed to absorb the same amount of heat as the substance does for 1 degree of increase of temperature. So water equivalent of a body, remember, equal to the product of its mass and its specific heat. Product of its mass and specific heat. What we are doing in case of water equivalent? Water equivalent is specifically we are doing. Suppose I am having water, some amount of water we are having and some objects we are having. So suppose object temperature I have increased 1 degree. Okay, object temperature I had increased 1 degree. So if I increase 1 degree temperature, so for 1 degree temperature increase I need suppose 5 joule of energy. So if this 5 joule of energy I am giving to water, so suppose I am having that 5 joule of energy if I give, so suppose 10 gram of water can increase 1 degree Celsius for this 5 joule of energy. So this 10 gram, remember this 10 gram is equivalent to this 5 joule of energy. Clear? So that is the water equivalent. Clear? So that is the water equivalent principle. Now coming to the next part of this chapter, that is called the equivalence of work and heat. Right now we will discuss that is called equivalence of work and heat. What is my topic? Let's write it. That is equivalence of equivalence of work and heat. Equivalence of work and heat. Clear? So what is equivalence of work in heat? We know, all of us, we know pretty well known about the fact that if I am doing some work, then obviously for that work might be possible heat energy generated, or if heat energy generated in a substance, then obviously there is some work done happen. Means Joule has established that law that work done is just equivalent to your heat. Means how much work you are doing, that ultimately will be converted to heat, and if there is a heat energy, means there some work has been done. So actually how much work you are doing, that is proportional to how much work you are doing, that is proportional to your heat energy. So from Joule's law we can write that work and heats are proportional to each other. So work and heat are proportional. Proportional. Okay, proportional. Means what? Work increases, heat increases. Means W equal to W proportional to heat. So from there we can write, to eliminate the proportionality sign we need a constant factor. So what we will do, we can write that W equal to J H. Means if H is multiplied with, I am showing you, wait, just giving an enlargement. Yes, so if H heat is multiplied with J, means heat energy equivalence principle, we will get our work done, and if work is divided by J, I will get my required amount of heat. So that is called heat energy equivalence principle. And remember that in CGS system the value of J is 4 joule per calorie. In CGS system the value of J is J equal to, remember, 4.2 joule per calorie. In CGS system it is 4.2 joule per calorie. This is the heat energy equivalence principle.